Dosage form calculations, the preparation and use of stock solutions, brought to you by Group 14.
Hey, I'm Jeffrey.
Hey, I'm Sarah.
Hey, I'm Shelby.
Hey y'all, I'm Feline.
And I'm Mia. Let's get started.
Our presentation today will include a handful of topics covering stock solutions, starting with what they are and why we need them. We will then discuss how to prepare a stock solution with calculations, the uses of stock solutions, and the administration of stock solutions.
First, we're going to discuss what stock solutions are. The definition of a stock solution is a concentrated solution that will be diluted to a lower concentration before being used in a clinical setting.
So why do we need stock solutions? Well, having stock solutions on hand saves time by knowing what concentrations of solutions you have versus what you may need. Stock solutions conserve resources and allows for more storage space. The accuracy of preparations is also improved when using stock solutions, so this improves time, resources, and accuracy.
We will now discuss our next topic, the preparation of stock solutions. Preparing a solution of known concentration is the most common activity in any analytical lab. The first step in preparing a stock solution is gathering the necessary materials. The second step includes working out the calculations to obtain the values needed to measure out. The third step involves measuring out the materials gathered in the first step to the values calculated in the second step. The method for measuring out the solid and the solvent depends on the desired concentration and how exact the solution's concentration needs to be. Pipettes and volumetric flasks are used when we need to know a solution's exact concentration. Graduated cylinders, beakers, and/or reagent bottles are used when a concentration may be approximated. The fourth step is actually preparing the final solution to be used. To prepare a solution with a known molarity, you weigh out the appropriate mass of the reagent, dissolve it in a portion of solvent, and bring it to the desired volume. To prepare a solution where the solute's concentration is a volume percent, you measure out an appropriate volume of solute and add sufficient solvent to obtain the desired total volume. So to recap, a stock solution is prepared by gathering the materials needed, calculating specific values, weighing out an appropriate portion of a pure solid or measuring out an appropriate volume of a pure liquid, and preparing the final solution in a suitable flask, and diluting to a known volume.
This problem demonstrates the calculations needed to prepare a stock solution. Percent, weight, and volume tells us the amount of grams per 100 mils. So, this problem asks us how many mils of a 17% weight and volume concentrate of benzalkonium chloride should be used in preparing 100 mils of a stock solution, such that 5 mils diluted to 60 mils will yield a 0.13% weight and volume solution of benzalkonium chloride. So, when calculating this problem, we want to first take 60 mils and multiply it by 0.13 grams over 100 mils. This gives us 0.078 grams of benzalkonium chloride in 60 mils, which is also the amount in the stock solution. Thus, the amount of benzalkonium chloride in 100 mils of the stock solution is 1.56 grams multiplied by 100 mils over 17 grams, and this equals 9.18 mils.
Hey you guys, so we have a calculations problem that we're going to work through. So let's first start with the question. How many grams of sodium chloride should be used in preparing 500 mils of a stock solution such that 50 mils diluted to 1,000 mils will yield a 0.3% weight per volume solution for irrigation? So what are we looking for? We are looking for how many grams of sodium chloride should be used. We start with taking the 50 mils and dilute that to 1,000 mils. This is going to ultimately make a 0.3% weight per volume solution. What does weight per volume solution means? It means that in this case, there's a 0.3 grams per 100 mils of that solution. Then, we try to use this information to determine the amount of sodium chloride in 500 mils of the stock solution. Take a second to solve this while I wait. Did you get this answer? Good job. Now let's move on to our next section. Now it is your turn to do a percentage dilution calculation. The problem is as follows. Calculate the amount of water you need to add to 95% ethanol solution with water to mix 100 mils of 70% ethanol. What is the unknown volume of 95% ethanol and the amount of water needed to make 100 mils? Try to determine which is the correct answer. I'll wait. Did you get B? Good. So that means we took X mils of ethanol times 95% ethanol equals the 100 mils times 70% ethanol. The unknown volume is 73.6 mils of 95% ethanol. To make the 100 mils, you subtract the 73.6 mils from 100 mils to make the 26.4 mils of water you need.
Now let's take a look at the use of stock preparations. Alright, now let's take a look at the steps of using a stock preparation. The first step is to pull the correct stock solution from the shelves. Step 2 is to calculate the amount of diluent needed. Step 3 is to compound the stock solution and diluent for the specific concentration that's needed. And step 4 is to double check all work before administering the preparation to a patient.
For this problem, we will learn how to prepare a fixed volume of a certain concentration from a stock bottle of a higher concentration. The problem reads, how would you prepare 250 milliliters of a 2 molar sodium chloride solution from a 5 molar sodium chloride stock? So for this problem, you would use the equation V1C1 equals V2C2. V1 is your initial volume, C1 is your initial concentration, V2 is your final volume, and C2 is your final concentration. For starters, you want to place your initial volume and concentration on the left side of the equation and set them equal to the final concentration and volume. Next, you want to rearrange the equation so that what you're looking for is alone. So in this particular case, we're trying to solve for the initial volume. After this, plug in the numbers and this should give you the answer you are looking for. So for us, in this particular problem, the 5 molar stock solution is the initial concentration. The 250 mils is the final volume you're searching for, and the 2 molar sodium chloride solution is the final concentration that we want. So once you plug the numbers in, you should get the answer that you were looking for. In this particular example, we got an answer of 100 milliliters. This means that dissolving 100 milliliters of stock will bring the volume to a 250 milliliter of working solution, with the concentration being 2 molars.
Now let's take a look at the administration of stock solutions. Here's a patient example calculation. So we'll start with the patient. MJ is a 27-year-old admitted to the emergency department at your hospital. And this is where you come in. A laboratory procedure calls for 250 mils of an approximately 0.10 molar solution of ammonia. Describe how you would prepare the solution using a stock solution of concentrated ammonia at 14.8 molar. So what do we have on hand? We have a 14.8 molar stock solution of ammonia. And what do we need? A 250 mils of a 0.10 molar solution of ammonia, or NH3. Now we look at wording. Of usually means we're going to multiply. This would group 250 mils and 0.10 molars together on one side of the equation. The other side is what we want. and that's what we start with. We have one component on that side, the 14.8 molar solution, but we need to calculate the volume. Now use the equation C1V1 equals C2V2 and solve for the missing volume. Keep in mind, this volume is the volume you have to dilute your solution you have on hand for the desired concentration. So you can then pull the desired 250 mils from that desired concentration.
Here's a look at some of the websites that we reference. Feel free to access any of them for additional information.
We hope our PowerPoint was very informational. To wrap things up, here are a couple take-home messages that we think you should remember. Always remember what stock solutions are, know how to calculate in both preparation and administration, and always double-check your work.
And to end on a positive note, we have a quote by Henry Petrosky that says, "All conventional wisdom has an element of truth to it, but good design requires more than an element of truth. It requires an ensemble of correct assumptions and valid calculations."
Thank you all so much for taking out the time to watch this video. We hope you gained a better understanding of the calculations used to prepare and use stock solutions.